Good afternoon, everyone. Here we are supposed to start our fifth unit, that is nothing but the passband digital transmission. So here in our previous unit we have seen transmission and the detection of the digital signal without any modulations. It means what? If we are not using any frequency shift modulations, we are saying that transmission and detection as a baseband communication or a baseband transmission. So here we can say in the baseband pulse transmission, a data stream represented in the form of discrete pulse amplitude we can take as a PAM. It means what? Pulse amplitude modulation. So we can say in a baseband pulse transmission, a data stream will be represented in the form of discrete PAM signal that will get transmitted over a low pass channel. And if we will talk about the digital passband, we can say the incoming data stream is modulated onto a carrier with fixed frequency, and then it will get transmitted over a band pass channel. So here we can say, if we will talk about the baseband signal, we can say this signal have significant power spectrum at low frequency. So they can be transmitted over a twisted pair cables, coaxial cable, fiber optic cable. But they cannot be transmitted over a radio link satellite because this would require large size antenna to take care of a frequency spectrum. So we can say baseband communication can be used only over a short distance. So if we are supposed to do the transmission of digital signal over a long distance, it will require spectrum of signal to be shifted in a high frequency region, and this we are calling as a band pass modulations. So here we can say band pass model of the detection process is equivalent to the baseband model because the received base band pass waveform is first transformed to the baseband waveform. So here we can say if we are supposed to do the transmission of a digital signal over a large distance, we can require spectrum of signal to be shifted over a high frequency, and we are calling that as a band pass modulation. So here we are supposed to modulate a carrier of frequency using the baseband digital signal. The amplitude, phase, frequency of carrier can be varied in accordance with the baseband signal, and the resulting signal is band pass signal, and this type of transmission we are calling as a band pass transmission. So here we can say when we are taking the received band pass waveform, it will get first transformed to a baseband waveform. So here we can take the equivalence theorem like performing a band pass linear signal processing, it will followed by heterodyning the signal to the baseband, which will yield the same result. So here the band pass signal to the baseband followed by baseband linear signal processing. So here we can say if we are doing the band pass modulations, it can be used to separate different signal over a single channel. So here we can see the different passband digital transmission, because passband digital transmission will allow more efficient use of the allocated area bandwidth and flexibility in accommodating a different baseband signal format. So here we can take any example, like we can take mobile telephone, we can take GSM. So here we are supposed to see the different types of the modulations. So we can say the modulations process will make transmission possible involves switching the amplitude or switching the frequency or switching the phase of a sinusoidal carrier in accordance with the incoming data, and according to this we will see different types of the digital modulations. These are nothing but amplitude shift keying, frequency shift keying, phase shift keying. So firstly we will talk about the band pass modulations. So here if we are using the amplitude of carrier, we are varied in accordance with the baseband signal. We can say that as nothing but a amplitude shift keying. So we can say the most basic form of the amplitude shift keying will involve the process of switching the carrier either on or off in correspondence to the sequence of a digital pulses that will constitute the information of signal. So if we are representing the binary data by the presence of carrier, other binary digital is represented by absence of carrier. But here if you see, frequency will remains get constant. If we will talk about the frequency shift key, so firstly if you want to see, we can see the diagram for the ASK. So you can see here, if you see, when we are giving the baseband data at that time, only there is an increment and decrement, there is a change in only in the amplitude. So here pulse shaping can be employed to remove the spectral spreading, and ASK will demonstrate poor performance because it will affected by noise, it will affected by fading and the intersymbol interference. So here now we can see about the FSK. As the name given, if we are changing the frequency of a carrier in accordance with the baseband signal, we can say that as a FSK. So if when the frequency of a carrier is varied in accordance with the baseband signal, we can say that as a frequency shift keying. And this is the most basic form of FSK, which will involve only varying the frequency of carrier by choosing one of two frequencies in correspondence to the sequence of digital pulses that will constitute the information signal. So here two binary digits are represented by two frequency around the carrier frequency. So here if you see, amplitude will get fixed, only there will be the change in the frequency. So you can see here the baseband signal binary frequency shift key, BFSK. So if we are using the FSK, we will get the change in the frequency, but here amplitude will remains constant. Now we can talk about the PSK. What will happen if the carrier का phase change हो रहा है? तो what we can say? We can say that as a phase shift keying. So if the phase of carrier is varied, how it will get varied in accordance with the baseband signal? We can say that as a phase shift keying, and it is another form of a digital transmission, digital modulations technique in which we are supposed to change the phase. Only there will be change in the phase, there will no, if you see here you can see in the phase shift keying there is a change in the phase. How? When we are changing the phase of carrier in accordance with the baseband transmission, we are calling that as a phase shift keying. So if we will say about the PSK, we can say ideally PSK and FSK have constant envelope. Due to this amplitude non-linearities encountered in microwave and satellite do not cause the detection. But if you see, practically ASK is not used in practice because ASK performance is very poor in more applications. So if we are doing the demodulations at the receiver, we can use two different methods. These are nothing but coherent and the non-coherent detection. So what does mean by coherent and non-coherent? So in coherent detection, local carrier generated at the receiver is in synchronization with the carrier at transmitter. Thus we can say the carrier at the receiver end is phase locked and with the transmitter. So we can say coherent detection is performed by correlating the received signal with the locally generated carrier. So we can say that is as a synchronous detection. So here if we saying the modulation technique which will employ coherent detection at the receiver, we can say that as a coherent modulations technique. And if we will talk about the non-coherent, how we can say? In the non-coherent detection, the knowledge of carrier wave is not required, or receiver need not be phase locked with the transmitter. Since we do not require the carrier to be recovered or the correlated with the received signal. So we can say that system will becomes very simple. But as here it is not require carrier to be recovered, we can say the detection has poor quality, so error performance of the system will degrade, and this method will called as a envelope detection. So the modulation technique which will employ non-coherent detection, we can say as a non-coherent modulations. So we can say modulation scheme is classified either as a narrowband or the wideband modulations. So here now we are supposed to see band pass transmission model, in which we will firstly see about the BPSK transmitter, which we will see in the next class. Thank you.